All right, in section 2 of chapter 4, let's look at a few problems to get you going. Um, so when determining the least squares regression line, and what you could do is to download the data into StatCrunch. We're going to go to a place where we can get everything that we want, the correlation coefficient, the least squares regression line, a lot of information, the scatter plot. So if we go to a regression line, so our x is our independent variable and our y is our dependent variable. Again, here's the stuff from section 1, the correlation coefficient, and rounded to some decimal places, like here is our regression line. So it gives us our y equals, here's our slope, the negative 1.09 times the x, and then a positive 103.4. So again, the y equals mx plus b. That's what we're finding here. Let's plug this in. So 2 decimal places. Again, I'm going to go with, I think these are probably rounded already to 2 decimal places. Negative 1.09 times x and 103.4. So let's check that. Awesome. And then the sum of the squared residuals. So here we're looking at residual is observed minus predicted. So there's something that we can do to figure this out. Make sure in here, this analysis of variance table, it'll actually give you what the sum of the squared residuals are. It's this number right here, this 52.7. Should be that total. We're going to verify this a different way, but let's see how that turns out, 52.7. And so that might take you a little bit of time if you were doing it an alternative way, but it's right there. Again, this is sums of squares, and this is our residuals. It can be looked as error. So a way that we could find that using a different way of doing that would be computing a expression. So if we took our equation, which was, it was negative 1.04, let's build it, sorry, times our x values, and then we're going to add, this is the thing I don't remember, I think it was 103, 103.4, good, 103.4, we can compute those values into this column. Now the residual, sum of squared residuals, is the difference of these things, and then we're going to square them. So I could, again, using the Excel-like features of my stat lab, compute an expression, and I would just want to subtract this column minus this column. So that gives me all the differences. If I square all those values, so let's again, using Excel features, Just kind of doing it one step at a time. Let's take this column and then square it. So again, all it did is square all these values. And if I add them up, I'm getting something bigger than the 52. Oh, now I gotta go verify my numbers. Oh, it was negative 1.09. That's where I made a mistake. So I'm going to go back to this column and build. Should have been negative 1.09 x plus the 103.4. Sorry, negative 1.09 times x and so here are those values now. And verifying these, I'm not sure it did anything. Here are those values, so it put all those values there. Nonetheless, you subtract them, you square the values, and then you can either add these up using or a calculator, or you could just do summary stats of a column. And so we're looking at summing up the squared. Again, I used 1.04, it should have been 1.09. And if you just want to find the sum, I could just click on that. And that gives me 75.2. Again, that number's off because it should have been a 1.09 that I used. But man, I'm telling you, if you just want the sums of squares, let's just do what we did previously. And that value is given to you right here. The sums of squares of the error. That's what a residual is. It's an error that we're looking at.